Recall from our earlier discussion, I mentioned the for loop in conjunction with loops that you do know at the beginning of a loop how many times the loop is going to run through. The for loop is used with this type of loop almost exclusively, whereas the while loop can be really used with either. Syntactically, the for loop is a little bit more complex than the while loop, which is why we learn the while loop first and then we learn the for loop next. Let's have a look at the syntax of the for loop. It looks like this. For, and then brackets, then there are three things inside the brackets. Three things, not just one thing that we saw before. The one thing that we saw before was the condition inside the while loop brackets and inside the if statement brackets. The for loop actually has three things and they're separated from each other by semicolons. The three things are an initialization. I'm sorry I haven't spelt that in full, but there wasn't room. Initialization, followed by the condition, followed by an increment. After that, it's pretty much the same as the while loop that we saw before. So, what does it do? How does it work? What's all these bits? What are they for? Okay, let's have a look at them. The very first thing that happens when you start a for loop is the initialization happens. That's the init apostrophe n at the beginning there. The initialization happens first, and it happens once only. It does not happen every time through the loop. It does not happen every time through the loop. It's a one-off affair. Next, the condition is checked in the same way that the condition is checked in the while loop, and in the same way the condition is checked in the if statement. The condition is checked, and if the condition is true, we continue on into the loop, and if the condition is false, then we do not go into the loop at all. So we go into the loop if the condition is true and execute any statements in the loop. Now, here's the complex part. Once the statements have been completed, the next thing we do is we go to the increment area and we perform that statement. It's some kind of statement. You'll see this in a moment when we look at an example. We perform the increment statement, and then we check the condition again. So again, at that point we can decide whether to go into the loop or we can decide to drop out of the loop. So we could go into the loop, then back to the increment, back to the condition. So I'll summarize that, and I'll add some numbers to this slide here. The very first thing that happens, the initialization happens. That's number one. The next thing that happens is the condition is checked. The next thing that happens is the statements are executed. Well, they're only executed if the condition is true. And immediately after the statement's being executed, the increment is done. And at that point, it goes back to number 2 and starts again. So it goes 1, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2. And it'll always stop on the 2. So if you like, you could do it like this. 1, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, and then that would end at some point in the future. That is how the for loop works. Let's have a look at a concrete example of this so that you can get your head around it a little better. Okay, here's our second while program again, although this time I've saved it as for.c. Now what I'm going to do is I'm going to rewrite this program such that it uses a for loop. And this is how I do it. Remember that we always need an initialization. I'll put the word for here. Now we need an initialization right about there, followed by a semicolon, followed by the condition, followed by a semicolon, followed by an increment. Okay. Now, typically, and I'm going to say this as a recommendation, but it's only a recommendation, it's only typically, the initialization and the increment have got something to do with counter. So typically it would be initializing counter, testing counter, and incrementing counter. That's typically how it works. So, is there an initialization of counter anywhere here? Yes, there is. It's this line, counter equals 1. So let's take the initialization away from there and put it here. Counter equals 1. Then counter is less than or equal to 1,000. Is there an increment of counter anywhere in this program? In case you don't know what an increment is a small addition. Is there a small addition to counter going on anywhere here? Yes, there is. Counter equals counter plus 1. I'm going to take that bit of code and cut, oops, and paste, counter equals counter plus 1. Now, okay, so far so good. I haven't explained it yet, and I'm about to explain it in a moment. But now notice that there's only one line of code inside the brackets, so we don't actually need the brackets anymore. We can get rid of them. This is what our program now looks like. For counter equals 1, counter is less than or equal to 1,000, counter equals counter plus 1. Recall, this is the sequence in which the statements are executed. That gets executed first, and it only gets executed once. In other words, it is an initialization. Then the test happens. Hang on, this is starting to look like the old while example. Exactly the same code's getting executed. Then this happens. Obviously, if that was true, then this happens. And then what happens? Well, then this happens. That used to be immediately under here. And it kind of still is immediately under there, only it's written up here. Now, once that's done, you go back to the test, the condition, to see if that's still less than 1,000. And so round and round and round we go into the loop. This entire line here describes the loop. If you think about it, this loop defines exactly the number of times that we're going to go through the loop. We're going to start at 1, we're going to go to 1,000, and we're going to go up by 1 every time. Everything about the loop is defined on the one line. That's what I like about for loops so much. It's all clear immediately what's going on. With while loops, in other words, with the version of this program that I just modified, the previous version, you had the initialization up here, the condition down here, and then 2 lines later you had the increment. So you had to really look around the place to find out how many times we were going to be going through the loop. Now that might not be a big deal in this program because there's only a grand total of about 6 lines altogether anyway. But when you get to great big sophisticated programs and the for loop starts here and ends 300 lines later, well, you really do have to go hunting around to find the conditions of the loop. It also makes the body of the loop really clear and concise. We're only doing one thing in this loop. We're adding a thing to the total. That's all we're doing. So that's another bit of clarity. That's why for loops make programs so much clearer. As soon as you know how to read this line, which is what I've just shown you how to do, your program should be immediately much clearer. But I guess there's still the question, does it work? Well, let's have a look. Compile, OK, and run. The sum of all the numbers is 500,500. Well, that's the same answer that we got before, so I'm going to assume that it's right. That is a classic example of the for loop. It's a very clean and simple for loop. As you can imagine, immediately before the for loop, we could have read in the maximum number of times that we wanted to go through the loop. In other words, instead of having it being hard-coded and set to 1,000, we could have a variable there called max, or something like that, and we could say printf, please enter the number of times you want to go through the loop. Or, let's be a little bit more explicit, please enter the total number of additions that you'd like to make, or something like that. And then do a little scanf, read the answer into max, put max here, and run the program like that. And I still want to assure you that at the time that the loop starts, we know how many times we're going to go through the loop. We're going to go through it max times. Okay, well,